Today we're going to continue with the conveyor, but I realized in reviewing what I said in the last lab project discussion may have been confusing. I was describing the system that we're going to build on, and I may have implied that that's what we were going to do in the previous lab, M9 and 10. And in fact, it's not. All that we did was one conveyor, and we did the size detection, the size fault. Now we're going to do, in this lab project, the 3 conveyor control with the system control. And it's pretty straightforward, and let's just get right at it. There's not much more to be said about it because I said a lot of it at the beginning of the previous lab. This is the system for this lab project, M11. 3 conveyor belts, each with a motor driving the belt. So that means there's 3 electric motors, 1 for each conveyor. We want a start and a stop push button for each conveyor. So each conveyor can be started and stopped individually. With an interruption in program execution or power, we do not want the conveyors to continue running if we leave the run mode and return to the run mode. So if the conveyors are running and we go to a mode change or lose power, when it starts back up, we don't want them running. We want system start and system stop push buttons that enable the conveyors to run, enable only, not run, or disable them from running. This does not actually start and stop the conveyors directly, just enables or disables the ability to start the conveyors. So you have 2 different types of start stops here, one for the conveyors and one for the system. Following a system stop, we do not want the conveyors to be running with a subsequent system start. So if any conveyors are running and you do a system stop, not a conveyor stop, but a system stop, all conveyors are going to stop. If you do a system start, we don't want the conveyors that were running before the stop to start up again. Each conveyor will have a unique rung of logic to start and stop them if the system is enabled. Now in the manual I said don't turn the page unless you want to see the solution that we are providing before you have exhausted your own imagination. And a tip, you may want to delete your existing logic and symbols before starting. We will not integrate the photoelectric eyes until much later in this manual. I started my lab project by opening M9, the template, which has the buffered inputs and buffered outputs, and then it has a program file for sequence that is empty. I renamed it M11 Challenge 1 Part 1 based on the name of the lab. One of the things that we discussed on the first page is something about I/O. If we look at the global variables, you can see our I/O. We have 20 outputs and we have 28 inputs. The lab project was written with a situation where there were 6 inputs wired up to switches, push buttons, and then 6 outputs wired up to LEDs. So depending on what you are working with, whether it's a hardwired hardware controller or the simulator, we're going to do the project with the virtual inputs, if you like, and the virtual outputs. But we're going to keep in mind that you could do this with these inputs and outputs here because the simulator has 28 inputs and 20 outputs. Before we go too much further, we originally created our template for 6 inputs and 6 outputs. That is buffered I/O. I'm going to up that and resave it with a different name. I'm not going to make you watch me do this. I'm going to do it and then come back. Beginning with buffered inputs, you can see that I have buffered input 0 to IN00 all the way through input 5 to IN05. I'm going to add 4 more to give a total of 10. To do that, I'm going to select this rung, Control C, and then Control V 4 times. 1, 2, 3, 4. Now you see that I have 5 rungs that reference input 5. Now I'm going to edit these, and you'll learn if you're an RS Logix user that the mouse clicks aren't quite the same. So I'm going to click on this and then click one more right behind the 5 and make it a 6. Now I could have just picked it right here, okay? So either way will work. So 5, 6, now I want this one. I can pick 7, this one 8, and this one 9. So now I have 5, which is the 6th one, because remember it starts with 0. So 0, 1, 2, 3, 4, 5, that's 6. 0 through 5, and then 6, 7, 8, and 9 gives us 10. Now over here, we're going to do the same thing. We select that, but remember, these tags don't exist. We created IN00 through IN05. We don't have a 6, 7, 8, and 9. Now we could go create them and then come here and select them. So I'm going to edit one of these. See, I get the little yellow triangle. Now I'm going to go to the global variables, and I'm going to go down to the bottom to the empty field, and I'm going to type in IN06, and it's already selected as a Boolean. Enter. IN07, enter. IN08, enter. IN09, enter. So now I just created 4 new tags here, Boolean type, in the global variables. So we go back to sequence, actually buffer inputs, and you'll see now that the yellow triangles are gone. So I expanded the input out to 10 buffered inputs. I'm going to do the same with the outputs, but not make you watch. Now I've expanded my buffered outputs. We were 0 through 5, now we have 6, 7, 8, and 9. And notice that these 4 tags or variables, I created those in the global variables and then edited the wrongs. In other words, I copied, we'll say output 5 is wrong, pasted it 4 times, and then edited the text. These tags already existed because they are module defined tags. By the very nature of a 48 IO controller, there are 28 inputs and 20 outputs predefined. So these tags were already defined. We just had to create these. So now we're going to go to sequence and add the first rung of logic. In the manual, you may have created these new variable names or variables in the local variable database. So we're in sequence, so this would be the local variables. I'm going to right click here, pick variable selector, and see, I can pick where I want it to go. So if I wanted it to go in the local variables, that's where it would go. If I created a tag variable right now and hit OK, it would be in the local variable. Later on in the manual, I have you transfer all of the tags out of local variables for sequence into the user global variables. So instead of putting them in the local, which is the default behavior when you create a variable while you're in a program, the default is to put it in the local variables. I'm just going to select user global variables, and I'm going to put it in here rather than moving it later. So start conveyor 1 push button Boolean, global scope, local scope, NA. So this might be confusing. Global scope, you may think that implies it's going to go into the user. Well, let me pick here. This is what I would want to show you. See, it still shows global scope, micro 850, but then it shows local scope sequence. So I'm going to go back and pick here because that's where I want it to go. But when you're doing local, don't get confused about this. So I'm going to say OK. And now I have a variable created. I'm going to create the rest of them as I just showed you and then come back. And there's our first rung. Then we had you save and download. I'm going to save. I need to create or initiate the simulator and select and power it up. And you may or you may not notice that I changed up some things in that I'm using the IP address of my wireless adapter. Now in an earlier lab, we went through a little convolution with selecting this IP address, and it didn't show up because, and I was wanting to use my local area network. In other words, the Ethernet NIC card that has a connector on it. Unfortunately, it doesn't show up unless it's plugged into something. So I actually connected a Ethernet cable between the Ethernet port on my desktop computer and a live Ethernet device out there. Then the IP showed up and I could select it. So that's a few extra steps and some confusion. So for future reference, you can use your wireless adapter. You just have to go in and select it when you set up your Ethernet IP driver. So now that we have the simulator created, or if you like, started and powered up. Now we can download to it. We also use the stop button in the same manner. We toggle that bit off and then toggle that bit back on. I typically, when I'm doing these projects, especially when I'm recording, I typically go offline. I save and disconnect, make the edits, and then download. In this case, because we did go over run mode change, I want to duplicate this wrong twice. So I'm going to go to run mode change to see how this behaves. We're in the edit mode. I'm going to click here and do Control C and then Control V twice. So now I have 3 rungs, and I'm going to go edit one number in each one. We'll just do 2 to begin with. We'll go ahead and do 3 as long as we got it up here. I think it's going to be simpler. One of the mistakes that I typically make is failing to edit one of my copy paste. So see, I got them all edited, and notice that the exclamation warning triangles are stating that these are not defined. So if I go to variable selector and I want them in the user global variables, do this one at a time. Always select user global variables because you can see by default it wants to go into the local variables. This may not be exactly the way I did it in the manual, but I wanted to clarify what you could do with your online edits. So right now we're in the online edit mode, run mode change. Now we're going to go test the changes. Right click here, toggle. Right click here, toggle. You may notice, this is version 12, you may notice that it seems like it takes extra mouse clicks in some instances. I think they'll get that sorted out eventually so it's smoother. Now we want to start the conveyors. So our logic works. We did this all online. Now we're not done yet. The test changes button changed color to show us that we are in the test mode. We're not going to request test. So the text that pops up here that says test changes, that's slightly a misnomer. It was test changes before we clicked on it. Now we're going to accept it. We could cancel, discard unaccepted changes, but we're going to accept them. And that puts us with 3 operating conveyors online in the run mode. And then we had to do a 4th rung. Actually, I didn't do these in order. I duplicated conveyor 1 logic for conveyor 2 and 3 without doing the system enable. So I'm going to Control C, Control V. And of course I can't do that in the run mode unless I put it first in run mode change. So once I put it in run mode change, then I can click here, Control C, Control V. Now I have 4 rungs, 2 of them for conveyor 1. So now I'm going to go actually create some new tags. This is going to be Start System Push Button. I have all of the variable names typed in on this new rung, and notice that they aren't actually data types yet. So I'm going to right click, variable selector, pick pick user global variables. Okay. User global variables. Okay. Now notice these 2 right here both have a yellow triangle, but both of them will be squared away once we define 1 because it's the same memory location. So the tags have been defined. The variables have been defined. Let's test this. We're in the test mode now. Let me show you something. We're in the test mode, not in the run mode, but we're running the new logic. If I try to edit, see, I can monitor, but I can't edit. Variable monitoring. I can toggle its state, but I can't edit it. I can only monitor it when it's running. So if I want to edit something, and I could go ahead and test this by, we'll turn on the stop push button. My pointer, I've made it larger so it's easier to see, but it's also a little sensitive to where it's located on the screen when you click on it. Then we want to turn this back off. Okay, so now we have 4 identical rungs logically. 3 of them control motors and 1 of them controls a bit called system enabled. Now I want to influence these 3 conveyor logic rungs with that bit. To do that, I have to add that into each rung. Now I'm going to go out of the test mode and back to the edit mode. See how this is blue, and then if you actually test changes, it changes to orange. So I clicked on this, so I basically went to test, turn on some bits, then I clicked on it again to go out of test. Now I want to add an instruction at the beginning of each rung, and we already have the tag. Now I don't like where it put it in, so I'm going to drag it down and try this again. And I think this is an issue with my cursor because I made it larger to be easier to see. See, I slipped off a little bit and it popped it over there. So I type in S, and I could go down to system enabled. There's a lot of things that start with S. By putting in the second character, I get right to it. I can just double click on it and it's done. Nope, see, my cursor clicked on what was above. Double click on it and it's done. See, we're in test. Now I'm going to click on this to actually test. So now we're back in test as soon as this assembles, and you'll see this changes color. See, it's orange now instead of blue. So I'm happy with these edits, so I'm going to accept them. Operating the system, I can stop a conveyor, or I can stop the whole system. All the conveyors stop. This is very straightforward logic. You have 4 identical rungs, with the exception that this rung of logic and its result, system enabled, is a precondition for all 3 of these. So if the system isn't enabled, see, I forgot to toggle the stop button. That would be like holding down the stop button, not releasing it. I just released it. So if the system enabled is not set, then it doesn't matter what you do with the start button. There again is another button that I toggled down and never released it. That's the reason that we're going to add some additional logic next that assists you in, instead of doing the double toggle, you can do a single toggle and get the same result as if you just pushed the push button and released it. We have some questions in the manual. Toggle any one of the stop conveyor push buttons off and back on. Did the conveyor stop? Yes, it did. Did it affect any of the other conveyors? No. Toggle the stop system push button off and back on. We did that up here. Did any conveyors stop? Yes. How many conveyors stopped? I answered 2 because I had already stopped 1. Did any return to the on state when you toggle the stop system push button off? Did any return to the on state when you toggle the stop system button off? No. Toggle the start system push button on then off. Did any of the conveyors return to the on state? No. Why? Because the system enable was removed, dropped out all the conveyors. We returned the system enable bit on, so now all of the conveyors are enabled to start, but they're not going to start unless you go through the process again of making the rung true again. We're going to stop here and then continue with this same lab project, M11, but we're going to call it M11B to keep these videos a little shorter. Well, this is really straightforward. I think this was very easy to understand. You're using seal-in logic, and you are using the decision from 1 rung to influence the decision of 3 rungs. That is, we have a system enabled, and then we have individual conveyor control, start, stop, ladder logic diagrams. So this was really straightforward. Now in the next lab project, which is part 2 of M11, challenge 1, we're going to continue building our conveyor system, or I should say our virtual conveyor system. We really don't have a conveyor system. We just have logic bits that go on and off.